in this slide, we are going to see the human impact on climate. So, while analyzing the human impact on climate, we have to see the impact of last 150 to 200 years human activity, that is also called anthropogenic changes, on the radiative forcing of Earth. So, when we talk about radiative forcing, so this basically refers to the difference between the incoming energy, that is the sunlight which is absorbed by the Earth, and the outgoing energy, which is infrared radiation emitted by the Earth back to space. So, as a result of greenhouse gases like carbon dioxide and other greenhouse gases, so there is a combined positive heating change to radiative forcing of about 3.6 watt per meter square. In the previous slide, we have seen the impact of aerosols. So, they have got a negative cooling change to radiative forcing of about 1.1 watt per meter square. Then there are some other small forcings also, so which lead to overall change of positive forcing of 2.7 watt per meter square. Now, we also need to understand other processes, and so there is always a possibility that there are other processes which impacts geological systems, and whether those systems may impact climate or not. So for that, there are different geological processes like tectonic processes, then output of sun, and then other variations, and El Nino, La Nina. So what is the impact of these? Whether they are leading to global warming or they are not leading to, so that we need to understand, and there can be questions related to this concept also. So coming to tectonic processes, what is meant by tectonic processes? So for that, you need to understand that the continents are moving over millions of years, and this continent drift can substantially alter the arrangement of continents across the Earth's surface. Now, when continents move towards northern or southern pole, so as a result of this movement, there is growth in ice sheet of the continent, and because these ice sheets are reflective, so there is a growth in continental ice sheet, so which will lead to more incident sunlight being reflected back to space, which will tend to cool the climate. So this is a very important concept, how increase in ice leads to reflection of sunlight and leads to cooling of climate. Now this process is exceedingly slow, and as a result of the movement of continent which occurs over millions of years, so these tectonic movements are not able to explain the 1.1 degree C rise in global temperature in last 150 to 200 years. Then the other geological processes which can lead to rise in global temperature is output of the sun, and we need to see whether the sun is getting brighter over past 2 centuries or not, or whether there is any long-term trend that could explain the rapid warming. So scientists have been observing sun's output for this period, and by using different instruments, they also measure the number of sunspots, and this has been counted for many hundreds of years. Also, they use chemical processes such as carbon-14 content of plant material, and these analysis suggest that sun has not changed its output over past few centuries. So again, this as a cause of global warming is ruled out. Then the third geological change is related to orbital variation. Now, orbital variation leads to different impact on the Earth's energy system. Now, solar energy reaches to Earth based upon the orbit in which Earth is moving and the degree to which it is tilted. So, as a result, when Earth moves closer to the Sun in the orbit, then the solar energy hitting the Earth would increase even if thermal properties of Sun do not change. So, in fact, Earth's orbit does change in 3 ways. So, which are those 3 ways where Earth's orbit changes? So, the first one is that shape of the orbit. So, when it is more whether it is more elliptical or less elliptical, and this happens over a period of 1 lakh years. Then the second is the tilt of the Earth. So here we know that Earth is tilted at about 23.5 degree, Now this cycles between 22.3 to 24.5 over a period of about 41,000 years. Then the date of closest approach of Earth to Sun, so which happens in January, and these cycles repeat for every 23,000 years, and these are generally responsible for ice ages, which we have seen in the previous slide. So these are not the causes of modern warming which has happened over a period of last 1.5 century. Then the other geological aspect which may be used or try to use to explain global warming is unforced variability. Now these are the changes forced by planetary energy imbalances. So to understand this, we have to understand that how Earth's climate system reacts, and first of all, this is very complex and it can also vary without any imposed energy imbalance. So such changes which are caused by complex internal physics of the climate system are often referred to as unforced variability. So as the climate system is very complex and there can be changes within the system itself. So which are the two types of changes which happen? From that also there can be a lot of questions. So those two changes are El Nino's southern oscillation is the first one, and the second one is La Nina. So in case of El Nino southern oscillation, also referred as ENSO, so these are warm phases of ENSO which occur every few years and last for a year, and these alternate with cooler La Nina events. Now can modern global warming be attributed to this unforced variability? So this is very unlikely because no theory explains the observed warming since the Industrial Revolution. So this global warming started happening since the Industrial Revolution, and there are no observations which support unforced variability. And the second reason is that there is nothing similar to the rate and magnitude of warming of the 20th century. And then the third reason is scientists use different computer simulations to simulate El Nina or La Nina or ENSO events, and using those simulations they are able to conclude that these are not the causes of global warming. So the global warming has been caused because of the anthropogenic changes, that is changes brought by the humans as a result of increase in greenhouse gas emissions. So the geological processes which we have seen here, whether it is tectonic processes or output of the sun or orbital variations or ENSO or La Nina, so these are not able to explain the global warming.